Okay, if this is the first time you've seen the symbol, it might look a little intimidating, but it's a summation symbol, okay? So what it says is you add up all the different options between k equals 2, increasing until you get to k equals 4, okay? So that means k equals 2 plus k equals 3 plus k equals 4. So it's nice shorthand instead of having to write out each of those. Okay, so that means plug in k equals 2, find out what it equals in this expression, and then add it to what k equals 3 equals, and then add it to what k equals 4 equals, and we stop at 4 because that's what's at the top here. Okay, so what this means is that we're doing 2 squared plus 3 times 2 minus 2 plus, because that's what the summation symbol means, add them all up. Now we're going to plug in 3. Then we're going to plug in 4. Okay, and so that's just a bunch of calculating. Just do it carefully, do the order of operations carefully. You got to do the exponents first. But let's see what else we got from this section. Same thing with this one. I'll let you do that one. That one's from 2 to 16. I think now is a pretty good time to show you this formula, okay? So 2 to 16 would be brutal, right? 2 plus 3 plus, plug in 2, plug in 3, plug in 4, plug in 5. That's kind of hard to do. So we have this formula. If you're adding from I equals 1 to n, okay, of the variable, I think we can give it any variable. If we call it the variable k, then the answer is going to be n times n plus 1 over 2. Okay, so this one, it's a little confusing because there's 3 different letters. I should say k equals 1. Sorry, I was using k. There's 2 different letters, okay? Makes it a little smaller. What this says is plug in k equals 1, plug in k equals 2, all the way up to like maybe you want to go to 100. Okay, so you can do that nice and easily. Instead of having to plug all of them in, you can just plug in what that highest number was. Plug in n. In this case, our n is going to be 16. Okay, and then multiply by n plus 1 and then divide by 2. So like a quick example is we know how to add, let's use a different letter, I equals 1 to 10, right? A quicker way of doing that is doing 10 times 10 plus 1 over 2. So if you were to do it without my trick formula, you do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. That makes 55. But if you use my formula up here, 10 times 11 divided by 2 gives you the same thing, right? So that's a shortcut instead of. Now notice the formula starts at I equals 1. So this formula starts at k equals 2. We got to back it up a step, okay? So we want to sum from k equals 2 to 16. That means we can't use my formula right now. Okay. Before we try to use it though, let's get it in a form so that we have it starts at 1. Okay. If you sum up from k equals 1, which is not quite our problem, it's a little more, right? It's got k equals 1 as an extra term. But then if you subtract out the k equals 1 term, okay, that gives you the sum of k equals 2 to 16. Okay, so you want to think about that carefully for a second. If you want to add up from 2 to 16, you want to use this formula. But to use this formula, it has to start at 1. So I went ahead and wrote that. K equals 1 to 16, that's the formula. But the problem I'm asked for just for the k equals 2, k equals 3, etc. So I subtract out the k equals 1 term. That way it's still the same problem. That way this equals is still true. Okay? Okay, so a little bit more detail before we can apply that formula. The summation operator acts like a linear operator, okay? Where that means it's kind of like you can distribute it. So the 3 can multiply on the outside, and then we can subtract it by the summation of k equals 1 to 16 of just the number 1. And we'll talk about that in a second. So look, I'm going to get rid of this color in a second, but I distributed the summation symbol. It's technically not the distributive property, but it's acting just like it. Okay, the summation operator, the summation symbol applied to the k, and it applies that minus 1 over there. Okay, and then while we're at it, let's do this. 3 times 1 is 1. 3 times 1 is 3. 3 subtracted by 1 is 2, so this is a subtract 2 over here. Okay, well, that's from a different problem. So to do this part, 3, oops, hard to write with a mouse. So we're summing from k equals 1 to 16. A quicker way of doing that is using my formula up above, okay? The n plus 1 over 2, okay? N in this case is 16. So I got 16 plus 1 over 2. So that's what this part came to be, okay? Now, this part right here, this is asking you to do k from k equals 1 to 16 of 1. Look, it doesn't change. It doesn't have a variable in here. It's 1 plus another 1 plus another 1 16 times, right? So if you add 1 to itself 16 times, that's like saying 1 times 16. And there's that minus 2 that we had trailing at the end. Okay, so let's figure out that fraction. That's 408, this term right here. And still subtract that 16, subtract that 2. So we got 390. A lot of moving parts there. Hopefully I didn't drop anything. Okay, so if that's the first time you've seen that symbol, it'll take some getting used to. Okay, they write, looks like, yeah, they use this slightly different formula. There's that you can look up a formula online. The formula for the sum of an arithmetic sequence that also does the same job. Okay. They have this subtract by. Let me find some blank spots. So they also have this formula available, which definitely works. Okay. The sum of a sequence. You take n, which is still the n is the value you want to sum to. Okay. And then multiply by a sub 1 plus a sub n over 2. The first term and then the last term you're trying to get to. Then you divide by 2, okay? N is the number of terms in the sequence. Oh, okay, sorry. N is different in their formula. N is the number of terms. So to get from, we're asked to sum from k equals 2 to 16. So there's 15 numbers in between 2 and 16 inclusive, okay? So that's why N is 15 in their formula. And then the first term of the sequence, that's if you plug in 2 in for k. 3 times 2 makes 6. 6 minus 1 makes 5. And then the last term of the, sorry, and I should be saying series. Okay. The last term of the series is if you plug in 16. 3 times 16 makes 48. 48 minus 1 makes 47. Okay, so if we do that, plus 5 times 15 divided by 2, it gets us 390, just like we did before. Okay, so I guess that formula is a little bit more cut and dry, huh? If it's an arithmetic sequence, you can use this formula. Just remember, n is different than the tactic I showed you. N is the number of terms in this series. All right, so let's apply that with this one here. Oh, but this isn't arithmetic, though. Okay, you'd want to do this like we did the first one, just doing it by hand, counting out all the different terms there. Yeah, this one you'll want to use that formula, okay? Summation formula. So just to help out with that, summation formula says take the number of terms in the series. So to go from 3 to 17, there's 17 minus 3 makes 14, 14 plus 1. There's 15 terms, including 3 and 17, okay? 3, 4, 5, 6, 7, 8, 9, 10. If you count all those out, there's 15 terms. So n is going to be 15. The first term is if you plug in 3. 3 times 5 makes 15. 15 plus 1 makes 16. The last term is 17. So 17 times 5 plus 1, that makes 86. And then divide that by, oh, I forgot what they did in the formula. It'll make sense probably when we see it. Did I lose it? How much should we divide? I think maybe it's just divide by 2 again. Because it's average of the biggest and the smallest term. Divide that 2, oops. So 16 plus 86 times 15 divided by 2, 765. Yeah, I should have wrote out the whole formula. Okay, this is your first term plus your last term divided by 2. Let's see what else we got here. Okay, same type of thing for that one.